RMR and Q are two classification systems that give a great way to quantify rock strength and quickly give both geologists and engineers useful information.
RMR is the most widely used rock classification system, and it was developed in South Africa.
These are the components to rock mass rating. So the first thing you need to take is an intact rock, UCS, and you just do that using a Schmidt hammer and then using the conversion chart to put it into megapascals. Your second component is RQD. You just need a measuring tape for that. You've got your mean fracture spacing, which will also use your measuring tape. Fracture conditions, groundwater state, and fracture orientation are all observations you must take.
For intact rock UCS, use the Schmidt hammer reading and use the conversion chart to put it in megapascals. For RQD is equal to the sum of the length of the core pieces greater than 10 centimeters over the total length of the core run times 100%.
With mean fracture spacing, you're going to want to measure the spacing of joint sets using a tape measure and figure out the average of all space in between the joints. For fracture conditions, you're going to want to observe the joint surface conditions and give it a label based on that observation. You can either have rough, tight openings, openings smaller than a millimeter, you have weathered surfaces, and gouges smaller than 5 meters and bigger than 5 millimeters.
A groundwater state in the outcrop can vary from dry to flowing, and that's just something you fill out on your RMR chart. And the final factor is your fracture orientation, and that depends on the project that you're doing your RMR for. They range from very unfavorable to very favorable. For instance, this fracture could become a potential side surface, whereas these fractures leave a stable slope.
When you finish measuring all the individual elements of RMR, it's time to find the overall rating. This is easy enough. Just add all the values together and you should get a number between 1 and 100. A higher number corresponds to a rock that is strong and stable, while a lower one shows a weaker and more unstable rock.
Q is another rock mass rating system, and it was developed in Norway for tunneling through igneous rocks, so it has slightly different applications.
So this is the equation for Q, and what you're going to do is you're going to have all these variables, and you will get the value for each one, along with the RQD value, and punch them into the formula and you will get your Q number.
RQD is found the same way as before, but the joint set number, joint roughness number, and joint alteration numbers are found using your observations of the number and condition of joints. Each description will give an additional value to use in the Q formula. The last conditions that contribute to Q are the joint water factor and stress reduction factor. And with these tables, the values are easy to find. With that, you can now calculate your Q.